Hi again. This is another very typical uh, type of examples for the first part of the course. Uh, and it says, represent each of the following combination of units in the correct SI format using the appropriate prefix. This is the important part here in the question. There are several ways that you can do that, but the elegant, accepted way, basically, I would say the only real rule is that you shouldn't use any prefix in the denominator except for kilogram. That's the only one because that's kind of the root in the SI system, kilogram. But the rest of them, the rest of them, you should try to express it if possible in the denominator without prefixes. So, for example, the first one, it says kilonewton. The root unit for the SI system is newton. Kilo means 10 to the third. You should know that, but if you don't remember it, remember there is a table here, kilo, 10 to the third. So basically, kilonewton will be 10 to the third newton. I'm going to put the newton here. And then microsecond divided by microsecond. And microsecond here, microsecond, I don't know what the symbol is, not here actually. It didn't print. But microsecond is 10 to the negative 6. So 10 to the negative 6 second. And those are the two root units for that. Now, if you do this, remember, this is powers of same base. So what you do is that you keep the base and you add the exponent, or you pass this to the top, and this is basically 10 to the 9 Newton per second. Now, could you express your answer like that? Yes, you could, but this is not the elegant way of doing it. So then you look at this 10 to the 9, and this 10 to the 9, basically 10 to the 9 is giga, and you have this one here, so giga. So that will be giganewtons per second. So that will be the answer for this one, giganewton per second. Done, part A. Now part B, megagram millinewton. Once again, we have prefixes in the denominator that we don't need. What do? Mega. What is a mega? A mega is 1,000 grams, a million grams. So we can say megagrams is 10 to the 6 grams divided by millinewton. Milli is 10 to the negative 3. 10 to the negative 3 millinewton. Newton. Now, what do we have here? What we have here basically is 10 to the 9, once again, grams per newton. However, and this is when things start getting a little bit crazy. Remember, gram is not the unit. The unit is kilogram. But you cannot say, oh, if I express this in kilogram, will be a million kilograms. And that doesn't work like that. So once again, this one here, 10 to the 9, is giga. And the answer will be in gigagram per newton. And that will be the answer for that particular part B. And the part C, this one here, then we have mega, 10 to the 6 newton, kilogram, millisecond, 10 to the negative 3. So let's do that. Mega newton, 10 to the 6 newton. And now in the denominator we have kilogram. Remember, kilogram is the accepted root for the denominator or numerator. So I'm going to keep the kilogram as kilogram. I'm not going to change it to grams. I'm going to keep it in kilograms. And later on, if I need, I will change it. A millisecond is 10 to the negative 3. 10 to the negative 3 seconds. This once again becomes 10 to the 9. So that with 10 to the 9 Newton divided by kilogram second, and 10 to the 9 correspond to giga, so that will be giganewton divided by kilogram per second. And that would be the correct answer for this problem in the correct units in the most elegant way that you can express those units. Thank you for watching, guys. See you later.